Welcome, everyone. Thank you for joining us for today's webinar. My name is Andy Davis. I'm your host today with Energy Safety Canada. And today we are presenting the identification of invisible boundaries of safety under understanding supervisor competency. Our presenter today is Dr. Michael Tabor, and as it is 12 o'clock, we are going to get started. All right, before we begin, today is April 29th. It is the National Day of Mourning. Every year on this day, we remember workers who have been killed, injured, or suffered illness as a result of work and work-related incidents. And we also honor the families and friends of those who've been deeply affected by these tragedies. It's a grim reality that in the oil and gas industry, we've seen over 300 fatalities in the last 18 years. That's an average of 20 deaths a year. That's a cold statistic that tells us we have a lot of work to do. So let's please share in a moment of silence to remember our fallen friends and fellow workers. All right, thank you. Now, before we get started, if you haven't already done so, if you can mute your microphones and turn off your video as well. That might be distracting to have a couple hundred people on video when we're presenting, so would appreciate your help with that. And we're also using the chat function within the Zoom platform here.
I was just, no, ask me that question again about dividends.
We don't need to know about that. All right, the chat function within Zoom here. So post questions at any time.
Well,
I'll
so
moderate
all the
those.
ones I give you pay dividends because that's the only thing I invest in is companies that pay dividends.
And just a reminder, folks, please mute your phones or devices or computers. Thank you. All right. So there is that chat functionality within there. We do have here on the screen how to access that. And we also have different feedback options available in the participant menu. So if you want to look on that, you can provide some basic feedback to us and to our presenters, just as a quick test so everyone can see the presentation and is the audio functioning for us today. Just a quick show of yes or no, please.
First of all, let me tell you how pleased I am with all of you because you all have been. This class
Okay. A reminder, we want to use that participant pane and out. 13, there we go. Lots of yeses. So I think we're in pretty good shape. And just a reminder for those who have joined late, please disable your video and mute your phone or devices.
Alex,
Thank you.
Alex, can you please do two things for me?
All right.
I want you to disappear. You're such a nice boy. I don't want you to disappear. So thank you.
Okay, just before we get started, we are going to have a quick poll so we can understand a little bit about our audience today. So let's see here. Can you answer, who do we have with us today? Do you represent field leads or supervisors, managers, office or support, or are you a field worker with us today? All right, about 120 of you have answered here so far. Results are still streaming in here quick. Again, people, please answer on the poll and not on the group chat. That's just for questions for our speaker.
Perfect. Very good. All right, now everybody ready for some.
And again, please mute your phones or devices, folks. All right, about 139 have reported in, so let's take a look. So about 60% office or other leadership. So great to see you folks here. and followed by support or service, and then team field leads and supervisors. All right. Okay, now it's with great pleasure that I'll be turning things over to our presenter today, Dr. Michael Tabor. Our presenter was scheduled to speak at the 2020 Petroleum Safety Conference that we did have to cancel, unfortunately, but we are very fortunate to have him here with us today. Dr. Tabor is an expert in the field of health science and has extensive safety management experience in both the private sector and heavy industry. So with that, Dr. Tabor, I will invite you to turn over to your presentation.
Thank you, Andy. I'm just wondering if you can turn over control here for me. There we go, we have it. And now I'm sharing. Okay, so welcome everybody. I'd like to thank you all for your time. And today I think it's important for us to think about these invisible boundaries of safety, and particularly those that are associated with supervisor competency. So as we talk about today being the National Day of Mourning, there's a number of incidents that I've been involved in the past, or at least been a part of the training and competency assessment processes. And one that's not too long past its anniversary now is the Cougar helicopter ditching. And I'll reference that a little bit as we go along, but there are a number of people that didn't return home, and I think it's important that we do recognize that. And when we think about the organizations that were involved in that, many of them don't look the same as they did before. So what I want to do is I just want to talk about some of the different components that we, let's see, for some reason, things are not advancing the way they should be. There we go. Okay. So we're talking about areas that are related to human and operational performance. And specifically, we hear the term human factors in quite a number of different areas. But what is actually involved in a consideration of human factors or human performance? And it's a wide-ranging number of factors. You can see all of them here on my display now. I've been fortunate enough to have the opportunity to work in areas related to survivability and habitability, fatigue, work with vibration and sound. And today we're going to focus on just one small component of that. But I want you to keep in mind that as we think about events that have ended in tragedy, or even just day-to-day operations, I want to think about how we're considering the environmental conditions, the individuals we're working with, and the technologies that are available. So when we talk about technology, obviously this is an extension of today's presentation and how we utilize that. And technology is great when it works the way you expect it to, but it doesn't necessarily always work that way. Humans are very much the same. So when we think about the operating parameters around the environmental conditions or the people or the technology, I want you to think about situations or scenarios within your own organizations about how you might be able to use the ideas or the concepts around human performance and these invisible boundaries to safety. We're going to cover 4 different areas. We'll start off with the principles of human performance, and then we'll move into some of the factors that influence competency. I'll talk a little bit about the complexity of systems and humans and that interaction. That's typically where we see human factors investigation lie, is that interconnection between those two. But then I'm going to introduce the construct of human systems integration, and I'll get to that as we move a little bit forward. But what I want to do first is I want to talk a little bit about what is this idea of invisible boundaries and how can we use those. So the idea was first introduced by Rasmussen in the late 80s, early 90s, and he basically was suggesting that every operating system has a number of boundaries that are around it. They're typically not visible, although we try to make them as visible as we possibly can. What we don't understand is necessarily how closely we operate to that position. So if we think about the envelope in the center of this schematic that's here, we can see that there's an operating point. So this is where we would typically have normal operations that occur. And this would be the original design parameters that are put in place for any system, and even humans working in an environment. So we would think this is where we normally would sit. And somewhere out off in the distance is the safety boundary that's been put in place either by engineering or economic failures or cognitive workloads. There's a number of different boundaries that surround this operating envelope. And this space that occurs in between what we think is normal and where those boundaries lie is where we operate currently. What we want to try to do is understand that over time, that operating envelope changes. So it starts to become larger and move away from the original planned boundary level at that normal operating procedure. So if we can understand that we tend to operate a little bit closer to that invisible boundary, then we're able to start to think about ways that we've normalized abnormal behaviors. I'm going to use the example of driving a car for the very first time at 100 kilometers an hour on the highway. For some of us, that was not too long ago. For others, it was a long time ago. And if you can remember way back, the very first time you drove the car at 100 kilometers an hour on the highway, it was either really exhilarating or absolutely terrifying, depending on where you were doing that for the first time and how you felt about the situation. So the first time we do that, we're within this operating boundary of 100 kilometers an hour. Then for some reason, whether we're late or we're just not paying attention, we start to drift from that over time. So the next time we drive, maybe it's 105 kilometers an hour is the maximum speed. We drive at 105 kilometers an hour and nothing happens. So we decide, well, I'm late again and I need to get there, so I'm going to make up a little bit of time. And I'm driving at 110 kilometers an hour, or 115, or 120, or 130, and whatever it happens to be, that becomes this new norm for us as we're operating that vehicle in hopefully ideal conditions. So we're sitting with a parameter now where we're out here, we've pushed this level out to a position where the car might not operate the way it was originally designed to. We might have an extra load, we might not have the brakes at the maximum efficiency. It might be raining, there might be some sort of material on the surface of the road, and we continue to operate as though we're well away from that invisible boundary. So when we think about this performance level, and this affects our capability to make decisions. If we have poor amount of sleep, we have stress, there's a number of factors, and I'll go through those as we get into the presentation. But what I want you to do is sort of think about in your day-to-day operations, can we identify where that outer layer is? And if possible, we're going to put in a space that allows us to move that through safety programs, through just our understanding of people's ability to perform at a certain level. Is there a way that we can move them back toward that operating point, that original point where we expected the system to be functioning? And if we can, we want to try to make that gap as large as we possibly can, that error margin. We want it to be as large as possible so that if we're in a situation where we can't always perform at our optimal level, then there's at least more of a safety margin for us to be able to do those sorts of things. So when we talk about principles of human performance, there's 5 overarching principles that are typically in place. And this comes from a number of human performance researchers, but most notably Todd Coughlin suggests that one of the overarching principles is that humans are fallible. We make mistakes. It doesn't matter who we are, how many times we've done something, we will at some point in our life make a mistake, whether it's intentional or not. So we think we're pressing the correct button, and we think that's what we're supposed to do, and we end up selecting the wrong button that's there. And this work originally came from the Second World War for aviators. And quite often what was happening at the beginning of the training for the pilots was that they would land without the landing gear extended. So how is that even possible? Well, in fact, what they were doing was they were grabbing the wrong lever. And what they ended up doing from an engineering standpoint is they just changed the levers, the dials and the knobs, to actually represent what the person was trying to do. So for an aviator, landing gear, they made the handle for the landing gear to feel like a tire. So when they reached down, they didn't have to look. They could just reach down, find the handle that felt like a tire, and they were able to lower the landing gear. So that made a huge difference, and it instantly stopped the events occurring where pilots would land without their landing gear extended, which is kind of an interesting thing. But we know that people tend to try to find shortcuts. So not only are we fallible, but we always try to make things a little bit easier for ourselves any way we can. And we'll put a lot of effort into trying to make the situation as easy as possible for us. So we cut corners. If nothing happens, we shifted the operating boundaries of that system, and we've moved much closer to that invisible boundary. So what we want to try to do is make sure that we consider all of the operational requirements that we have and what that envelope looks like. Because if we can identify these likely situations where we're going to have an event occur where people are going to make mistakes, so we've overloaded them, we've asked them to do too many things, whether it's the environmental conditions, it might not be the middle of July, nice and dry conditions, it might be the middle of February, it's freezing cold, icy, slippery surfaces. So if we can identify those and they're predictable, then we should be able to manage those, and they should be preventable. Because if we start to think about, okay, well, how close are we operating to that invisible boundary? We should be able to deal with those. We know that individuals are influenced by the organizations, the practices and procedures, the values that are in place. So safety culture is a really good example of that. Organizations that have a really strong safety culture typically have been through a number of events. So Cougar helicopters, they're unrecognizable now from before the event to where they are now. They've changed a number of things, both from a personnel standpoint and an engineering standpoint, to try to move themselves closer to that operating, that expected envelope of performance, and further away from those invisible boundaries, and trying to, at every point, figure out a way to make sure that we're much closer to where we want to be. And we also know that humans tend to perform better if they're rewarded, if they receive encouragement. We can see this with kids all the time. It doesn't matter whether it's a school subject, arts, or sports. We see that if we give kids praise, they tend to spend more time and put more effort into becoming better and better at it. So we self-select. Adults are no different. We tend to self-select. If I'm really good at something, I tend to gravitate toward that. So if we can identify those individuals who are quite good at it and start to gain some information from them, and that's the last principle, is that if we can incorporate the lessons learned and talk to the people that are actually performing the skill at a very high level, very close to what we expect the system to be operating at, then we have a better understanding of how things are going to occur over time and how far away we move away from that invisible boundary. So let's just quickly jump into the competency component. So when I think about competency, or when we look at it from a human performance perspective, we're really talking about, is the person capable of doing the task that we ask them to do? Just because they have certification and they're compliant does not necessarily mean that they're competent. And I think every one of us can think of someone in our life who is a really bad driver. And they may have been driving for 30, 40, 50 years, and they're just really good at being bad. They meet all the criteria of being considered an expert. So having their 10,000 hours performing a task over and over again, they meet that criteria of being an expert, but they're an expert at being a really bad driver. So I know a number of people in my life that are like that. And that's really what we're talking about, is that not the fact that they have performed the task a number of times, but have they done it really well? And have they become competent to the point where I'm willing to allow that person to do that task and have no worries about them? So from a supervisor's point of view, being able to assess the individual, we need to think about three different things. First of all, the person who's doing the assessment process, think about the standards that are in place and the measurement techniques. And that includes a number of different areas. So we already talked a little bit about safety culture. We haven't mentioned too much about safety climate, but safety climate is when an event occurs. And there's been a number of researchers in the past that suggest that the climate in an organization is a perfect opportunity to change the way things are done related to safety. But if we just allow the event to occur and nothing happens, people will eventually revert back to the safety culture that was in place prior to the event occurring. Cougar Helicopter is a perfect example how they took the event and said, we need to change. We need to make a difference so we don't ever have this happen again. And they started looking at all of their assessment processes. They started looking at how they trust automation, technology, how they identify risks, how they make decisions, what their risk tolerance is, what sort of internal checklists they have, what sort of tacit knowledge do they have in their organization that they can pass along from people who are considered really good, really competent at what they do. So if we can start to address those things, and that's what we're going to do as we go through, then we get a better understanding of how we can practically apply this idea of invisible boundaries of safety and competency. So if we think about the assessors, they may have been promoted into that position. They may have taken a number of courses to get hired on to be a supervisor, but it really depends on the organization, the situation. And this idea of invisible boundaries is not just for the oil and gas. It stretches across all different applications. So when I think about an assessor, it could be a senior pilot, it could be an installation manager, it could be any manager or anybody who's in charge of other people's work. And we think about how they got to the position that they're in and what sort of certification they have. And if there's any sort of certification process that has to be renewed. Because if not, then what ends up happening is there's this process of drifting away from the original parameters in the training process. So this rate or drift is based on experience that individuals have. So for the oil and gas industry, for example, if we're looking at the installation managers, there might be 6 key factors that are used when we're assessing the performance of individuals, either in emergency management or just their normal operations. And where we focus our attention when we're doing that assessment will play a factor in whether or not we think that person is competent. And over time, that will change. We gain experience. We've talked with other individuals in the same position. We've been through events, and we start to think about, well, okay, I think it's more important for me to focus on X, Y, or Z. And we drift away from the original. This is much like the operational envelope. So as we drift, if we don't sort of reevaluate what it is that we're drifting toward, then it's hard for us to know whether we're going to be in a position that's going to be beneficial or not in the next event. The validation process comes down to the SME's experience and the minimum qualifications. And that's one of the concerns that we have with a number of training processes or competency processes, is that there is a bare minimum requirement for people to become certified. And if that's the case, then when we start to talk to people who are actually in the field doing the work, we have this notion of ecological validity. Is it actually going to work? So something that's written on paper or that I've taken in a classroom for one day or a week or however long the process is to become certified, is it applicable in the real world? And when we're doing that, we need to sort of think about how humans perform. And I just put up this one little graphic here to give you an idea of one component related to how humans perform and how even assessors are affected by this. So we can see that from the biological clock, and this is really diurnal clock or circadian rhythms that occur in everyone. And this one's based on a normal day shift worker. And we would say that at the very onset of the day, we start to see changes in testosterone, and melatonin is stopped. And that's basically, we're in a situation where we're trying to wake the person up a little bit more. But we have the highest alertness at 10 a.m. in the morning. This is on average. We're most coordinated at 2:30. We have our fastest reaction time at 3:30, and we're strongest at 5. So if I'm going to do an assessment, or I'm going to plan out this process, we could take into account some of the known factors, physiological factors, of how people are going to be able to perform a task, just based on normal circadian rhythms that occur. Shift workers that are in evenings are different. So it takes time for that to change. And we know that Mondays are probably the worst for most people. And the last day of a hitch for the oil and gas industry is the worst for errors. And that's because people's brains are on getting home. Other things that are going on. They're fatigued. They've been doing this job for the last 14, 28 days, depending on the rotations. So we know that those periods of time are difficult for individuals. And if we know that, so those are the predictable ones, we should be able to manage those, and we should be able to prevent them. Perhaps we don't schedule a really challenging task for the end of a shift. When we make these handovers from one shift to another, understanding these limitations for somebody who's just coming on is an important component. When we think about those invisible boundaries, that's definitely one of them that we'd start to think about or start to consider. So when we think about the standards that are in place, these are typically agreed upon standards, best practices, and they're usually accredited. So if that's the case, what we need to do is start to think about, well, are they applicable? That's really the biggest component, is that if they're not applicable to the situation, then they're just not going to work. If the procedures that are written down in documentation, so our standard operating procedures, don't apply in the field, we just can't do the tasks the way that they're written down because of whatever constraints, so whether there's time or pressure, whatever it happens to be, then those need to be changed. And quite often the standards are not task specific. So if you take a confined space course, for example, and we say that somebody's competent because they're certified to the standard that was used in the training environment. But can we then move that to an environment where there might be a lot of other things that are going on? And just as an example, for the offshore fire teams, did a bit of research in the past looking at the ability for the individuals to perform casualty extraction. And all the individuals were fully qualified, competent. They've been doing this for a number of years. And we just basically wanted to look at benchmarks and try to identify whether or not there's a physiological component to performing the task if we change up the area that they have to move the individual. So as we start to talk to the individuals and say, okay, what are the tasks? What do you guys need to do? And what is the heaviest person that you have to work with? And a number of the individuals said, well, we've got somebody who's working on the platform right now who's close to 300 pounds. Said, okay, perfect. That's exactly what we want to know. What's the worst possible position that person could be in? Okay, so we start to mock those up and think about, what are those boundaries? What limitations do we have, and how far away from that safety boundary are we working? And those individuals, when we mocked up a 300-pound mannequin, were unable to perform the task in the time that they needed to, or with the equipment that they had. So it becomes extremely difficult for them to do that in a practical application. Now, that is a bit extreme, obviously, but it's something that needs to be considered if we're thinking about hazard assessments and risk assessment. So the measurement techniques, that we use in that case and in a number of cases were not only just the subjective measures that we typically see, so KPIs and KSAs and the surveys that are done. Those are subjective and based on the understanding of the individual who's filling them out, or considering all the different parameters that they can consider. And if they have an internal checklist that's not available for others to know exactly what they use as an evaluation criteria. So when I'm doing the competency assessment as a supervisor, if I'm filling this out and no one knows exactly what my internal checklist looks like or what I prioritize, then it becomes difficult for us to identify what that level of competency actually is. One of the things that we're starting to look toward is now bringing in real-time physiological measures. So in some cases, people are wearing fatigue bands, so Ready bands or Fitbits or a number of other measures that are used to augment the subjective ratings and say, yes, okay, well, if we could understand the individual's heart rate, breathing rate, and even galvanic skin response, so that's an emotional stress response, then maybe we'd be able to say, oh, wait a minute, we know that 80% of our people are performing a task at a level that's well beyond what they should be physiologically. So their breathing rate and their heart rate is through the roof. And if we've got them using a self-contained breathing apparatus or some other device that's helping them perform the task, we might be pushing the limits. Cognitively, we're starting to do some work with eye tracking, and I've been doing that with the offshore pilots over the last 3 years and trying to identify radial scans. So in the display that's here, we're basically just trying to identify the areas that the pilots would look if an emergency occurs. And could we take that information, so that's tacit information in their head, not available to others, could we take that information and build a model that showed the radial scan based on an engine failure or whatever event is occurring? And in fact, we were able to take novice non-pilots right off the street and teach them how to perform an auto rotation, dual engine failures, and land the aircraft in a very short period of time, simply by showing them what they need to look at. So that was unavailable previously. But these are the things that we start to think about. If we can start to identify where these boundaries are and what we can do to make it a little bit easier for people to understand, then we put them in a much better position. So when we think about human factors or human performance evaluation, we typically use two sort of focus areas, and one would be the system approach and the other would be a human approach. And when we think about system approach, we think about engineering solutions, alarm systems, fail-safe systems. So if you can think about a USB key as a really good example. So a thumb drive. There's only one way to put the thumb drive into the USB port of a computer. Well, theoretically, okay. First time we try, it's typically not the right way. The next time we try it, it's not the right way. And then we put it in the third time exactly the way it was the first time, and it goes in. But if you look at the end of a USB key, you'll notice that there is a piece of plastic that prevents you from putting it in the wrong way. So this is an engineering solution to make sure that people don't damage their equipment by putting it in the wrong way. The same as a number of fitting devices that are on pipes and connectors that we find for even just something as simple as a key. It's designed to go in one way and only one way to work properly. So if we can start to think about that component, then that's exactly where we look at our system approach. From a human perspective, we're a little bit more nebulous. So decision making, it's not necessarily obvious for us to be able to identify what someone's decision-making process is. We have a number of biases. So if we look at an accident after the fact, we have hindsight bias because we have all of the information available to us at the moment that we're doing the investigation. But people don't know what they don't know. So in the moment where the event is unfolding, there's information that may not be available to that individual, and they're making decisions based on that mental model that they have of what's happening around them. So there's situation awareness. And if they don't understand all of the information that's available, then their decision was valid at the time that they made it. And we tend to see that with the invisible boundaries of safety. When we do these retrospective analyses, we can say, well, no wonder the person had an event or there was some sort of catastrophe that occurs, but they didn't get there overnight. They slowly, incrementally move that position further and further away from the normal operational envelope. And if we bring someone in new and they start at a point where they're already removed from that initial point, then we're in a situation where those individuals don't even understand how far away they are from the normal operating boundaries and the safety boundary. So we know that there's a number of aspects that we can address through ergonomics and physical capabilities, but there's a number that we can't just by using a human approach. So if we try to integrate those two aspects, so from a systems factor, we can do our risk tolerance assessments, we can try to keep people in the loop as much as we can. We try to fit for purpose some of the engineering stuff. We think about lighting, noise, vibration, environmental conditions, the safety culture and the safety climates, SOPs. So we try to think about all these things that are added into the system, and we're trying to integrate those into how we deal with the humans. So we can start to think about what could we put in the system to identify these limitations. So one of the most useful tools is a functional task analysis or hierarchical task analysis. We basically get people to tell us exactly what they do to perform a task from beginning to end. This is called declarative knowledge. So they can tell us every single step that they need to. But if we don't write that down, then it's lost, and it's tacit knowledge. It sits in the person's head and it's not available for somebody else to have a look at. This is a really great way to look at competency. So if you can have someone write down, okay, every single step, in this case, I just use an example of someone monitoring water flow. So that would be the overarching task. And then you start to think about, there's 1, 2, 3, 4 main tasks that are there. And we're trying to think about what are the subtasks that are there. And this can be any operational task. It doesn't really matter what it is. But once this is produced, this hierarchical task analysis, others have the capability to look at it and say, oh, there's a gap. Then you missed something, or we need to address something here. There's a question mark. Well, how do you do that? Okay, well, now we need more subtasks. And when I was working with a couple of aviation companies, we were looking at their bow tie risk analysis. So we have the top event was a controlled flight into terrain, and it's one of the most notable events that occur within the aviation industry. Perfectly certified pilot, been flying the aircraft for a number of years, and the most recent one that comes to mind is the Kobe Bryant helicopter crash. So that pilot's fully competent, has flown in those conditions before, was not certified, which is a different story. But if we were able to step back and say, okay, what are the things that we need to do? And if there's a limitation that's there, how do we address that? In the aviation world, one of their barriers they put in place was to say, okay, well, human factors. And I questioned the entire group. I said, well, what's in the human factors? Okay, well, hydration, caloric intake, the amount of sleep, exercise, stress levels. Can we answer any of those questions? The answer is no. It's a big question mark. So if there's a question mark in your risk analysis, you really can't identify how things are going to unfold in those situations as they occur. So if we're able to start to create this linear process, then we're in a situation where we can start to put in these boundaries. So this is a model basically set up by James Reason in the late 90s, early 90s, late 90s, and refined over a number of years. So if we put in these layers in our system and we say, okay, each one of those are going to act as a boundary to an event occurring. And Reason's idea was that each one of these boundaries will have a hole in it somewhere. So he used the idea of Swiss cheese. And if all the holes line up, then an accident occurs. And we retrospectively look at it and say, oh, well, of course, look at all these holes. But what we're trying to do is trying to think about, what if we start to get those boundaries set up ahead of time, and we think about where those holes occur and try to make sure that that system isn't going to fail for us. So if we start to consider the human factor side of things, and I have already mentioned a number of these things, but thermal regulation is a really good example for working in the oil and gas industry. Wide range of environmental conditions. So hot, cold, dry, frozen, you name it. There's lots of different environmental conditions that we would experience out in the field. And do we have a good handle on cognitive and physiological performance for the individuals performing that task? So how competent can they be if physiologically they're limited? A really good example of that is hydration. So we know from research that if you lose 2% of the water that's in your body right now, you lose 20% of your physical capabilities in ambient room temperature. That's a lot. There's also research that that's suggesting we also lose 20% of our short-term working memory. So now we've lost our short-term working memory to a certain extent. And for some people, that's a pretty hard hit. Not any of you that are out there, but I know a few people that if they lose 20% of their capabilities, that they're not going to have a whole lot left. The physical performance, being able to manipulate objects, we've already lost 20% if we just have them dehydrated. Now, if we put them in a cold environment, we know that we don't thermoregulate nearly as well, and we start to draw blood back into our body core as we get cold. So now our manual dexterity is hampered and our cognitive performance is hampered. And this is part of that invisible boundary and trying to identify that. The complexity of tasks. So if we move to the cognitive component, understanding workload and expertise, what available information there is, and really trying to think about how people are going to perform on any given day. If we remember that people are fallible and we know they're trying to cut corners to make things easier for themselves, then we can start to identify those boundaries. We know that anthropometric differences, so tall, short, long arms, really long legs, they all play a factor in how people perform. We know that sex, age, tolerance to all sorts of different things. So injuries, we know that they all play a factor in how the person's going to perform. So I wanted to show you just a little video here from some of the fatigue management group that I talk with regularly. And this happened recently in a warehouse. So when we think about the invisible boundaries to safety, I'm going to draw on the video a little bit after we let it play. It's only a couple seconds here. But I want you to think about if you can identify where some of these boundaries might lie in this situation. So let's just play that. Okay, not having a good day. So when I look at this and I think about the invisible boundaries, this is from the fatigue management side of things. You can tell that the worker was obviously not doing all that well, head down in his hands, not watching where he's going. But if we understand that humans are fallible and they're going to make mistakes, then we could quite easily have put in barriers along the outside of these racks and said, okay, if somebody, for whatever reason, is going to fall asleep at the wheel, they could hit these boundaries and cause no damage. We could also consider, well, what about the fact that we have all of these racks connected together? Maybe that's not a great idea. Maybe we want to start putting some sort of monitor on the individual and say, man, their heart rate is not where it should be. It's really low. Their breathing rate is really low, which would indicate that they're sleeping a little bit. or a little bit sleepy, pardon me. Blink rates. So if we could have safety glasses that start to look at monitoring of their pupils and their blink rates. And we know that all of these things are available. The technology is there. It's just being able to integrate it and understand how it helps us identify these outer limits. So we're almost finished up here. We've got the last couple of slides. So from a human approach, we want to think about the bona fide occupational requirements. And if you can think about the ones that I'd mentioned related to the firefighters, that was a bona fide occupational requirement for them to be able to lift a 300-pound person up a set of stairs, through the hallways, around a bunch of corners in a stretcher. Okay, well, if that's a baseline standard that we use to identify what's actually needed in those, and I'll just bring up this section, is that if we can think about them performing the tasks under all conditions, not just ideal conditions, but all the conditions, does that change the way we train people? Does that change the way we select the individuals that are going to be doing the tasks? Absolutely, 100%. If I put 1,000 people in that situation, so that worker that's on the little cart driving around that warehouse, if I put 1,000 people in that position and get them to go through the exact same thing that they're going through right now, so ask to do a lot more work on a lot less sleep, is there going to be more than one that will make that error? Absolutely. There's no question in my mind. So is it a human error? Is it a system error? Well, maybe. But I think that there's another way to look at it, and that's what we're going to be getting into here in a second. So can we use simulation? Can we use augmented reality to develop these bona fide occupational requirements? Can we use objective measures? Absolutely. It's being done in a number of areas. So that brings us to the last area that we're going to talk about, and that's the introduction of human systems integration. So basically, it was developed for NASA in the late 80s, early 90s, and trying to look at the gaps that occurred between this human and system approach in human factors, and starting to consider the human, the environment, and the available technology that's in a system. How do we start to integrate this and allow it to work to our benefit as opposed to becoming a barrier for us? And it includes things like habitability, survivability, safety systems, occupational health and wellness, HR. And really, we're trying to keep the human in the loop at every single stage and try to think about how they are influencing the process. So I talked about functional task analysis. Basically, if we can use that to our advantage, and that, like I said, is probably the number one way to create a greater understanding of situation awareness. So I've put HSI at the top of this. Basically, our technology, our human, and the environment. And that leads into human factors engineering, health, and usability, and functionality, and all those sorts of things. But when we get down to it and we say, what does the person understand? How do they approach the situation? Can we give them the ability to not only perceive that invisible boundary, but to comprehend how important that is, and then to be able to predict what would happen if I do X, Y, or Z. If there was a way to use simulation, and the aviation world does really great with that, the medical community is starting to use that a lot more than they used to as well. Is it applicable to the oil and gas industry? Absolutely. And there are some organizations that are using simulation to be able to help create this greater understanding of what's going on. And then to integrate some objective performance outcomes. That will increase our survivability and reduce the number of errors that occur to a certain extent. Obviously, we're never going to get it to zero, I think, unless we take humans out of the system. And even when we do that, if we have a human monitoring the system and we hand it back to the individual and they don't comprehend what's going on behind the scenes, so we've got this automation that's completely controlling the situation, and then an event occurs and we hand it back. So an example of that is the group that works off of the Hibernia platform in Newfoundland. The original design for the alarm management system was set up that if there was a complete system failure, the operators would be so inundated with so many alarms from so many different systems their standard operating procedure was to shut down the entire system for 2 minutes. Everybody sort of gather their thoughts, figure out what they're going to do, restart the system, and then methodically go through each one of the alarms and clear those as they could. 2 minutes is a long time in the middle of an emergency, and it's been changed. The system has been changed to try to help keep the human in the loop a little bit more so they understand exactly what's happening. Longford Gas Plant is a similar situation as well. So Piper Alpha as well is a similar situation, to be able to understand exactly what's going on in the system. So this indoctrination process that occurs with the individuals, could we indoctrinate individuals into a system to understand that there are these invisible boundaries, and how do we create a better understanding of what's going on? Can we use an event to identify a new norm? And the answer is yes, absolutely. We've seen it a number of times in organizations where they're able to say, these are the limitations of our current safety culture. What do we need to do to change that? And unfortunately, we tend to be fairly retrospective. We tend not to be proactive. We tend to allow an event to occur, and in some cases, people die. And we say, oh, we should have changed that. And I know from personal experience a number of things that I wish I had changed before an event occurred, even though it was identified and we knew it was going to be a problem, and we say, we should be changing this. There wasn't a lot of push from all levels to say, we need to be making a change. And I personally know 2 individuals who died in a helicopter event for the military that I trained prior to the event. And one of the individuals just a month and a half before the event occurred. And always looking back and saying, did I do enough? Did I think about how this person would be able to perform and identify the areas that we could make a change? And they were identified, but they weren't followed up on. So that's really one of the things that we sort of need to be thinking about, and how we can start to integrate the technology. And I've already mentioned a number of these things. So we're getting down to the last little bit, limiting factors. What are those invisible boundaries in your organization, in your processes? How do we start to think about those, and what sort of risk and hazard analysis? The number one thing I would do is talk to the people who do the job. Get out there and say, what do you need to do this job? How do you do it? Does it look like it says in the documentation? If the answer is no, why not? What do you need as support? How do I build capacity in that space? What sort of certification do we need to go through? And what do these competency assessments need to look like? If we can identify all of those, then we're going to move ourselves much closer to that expected operational envelope, as opposed to being away from it. So if we can consider all of those and bring ourselves back into that space, right in here, our error of margin, right here, gives us a lot more opportunity to deal with a situation if it occurs. If we're sitting way out here on a regular day, what happens when it's cold, nasty weather, people are tired, they're not well fed, they haven't gotten a lot of sleep, they're stressed out, there's a whole bunch of things that are going on? Well, something's likely going to happen. We want to try to move them back into the position as close as we possibly can to here. So with that, I'm going to end the presentation. I'd like to thank you all for your time, and I think we're opening up to questions now.
Yes, thank you very much for that, Michael. We did have a couple of comments during the presentation. No questions yet. I did get a couple sent to me privately here, so just one moment. Where should a person focus their efforts to best educate frontline workers of the invisible boundaries of safety?
That's a really great question. If we sit down and we talk openly about what it takes to perform the task, like honestly performing the task, not what it looks like on paper. If you can spend the time as supervisors talking with and some of you may have performed the task in the past, and you understand that they don't look exactly the same, and they don't look the same every single day. If you focus time on getting an understanding of what that looks like at the beginning of a shift, toolbox talk or safety talk or whatever it happens to be that you use in your organization, if you sit down and say, okay, today we're going to do X, Y, and Z, and you say, I want people to honestly tell me what the limitations are. Where do we see the boundaries for that? Then you're much more likely to have people, and if you're open and honest and make the changes and put in the effort to provide individuals the capacity to do the job that they need to and increase their competency level, if they take the same course day in day or every year, the exact same thing, it never changes, they don't increase their competency level. If we give them the opportunity to increase that by providing them with whatever they need, that's where you're going to have the greatest benefit. And that's where I like to focus it. When I go in to do an organizational performance evaluation or competency assessment, I sit down and talk with the guys and say, what do you need to do this job? What's the pilots are a really good example. I talk with the new pilots being hired into an organization and said, what would really help you out? What do you need to know that you don't know right now? And they said, well, it'd be really nice to know, even though I'm competent or considered competent, I'm certified to fly this helicopter, I don't know what the training pilot is thinking or using to evaluate me. Okay, well, we bring the person in and we say, what are you using? Let's go through a scenario. And I did it over and over again with them. And the new pilots were amazed to understand what it is that the supervisor was evaluating them on, because they didn't know. And once they knew that, the difference was amazing. It was a very rapid change, and people understand now, even just something as simple as telling someone where to look, when to look, that made a huge difference. So hopefully that answers the question.
I think that was very good. All right, I'm going to combine a couple of questions here. We're short on time. First, do you know of any research involving personality traits of workers that fits with these concepts? And then, do you have any other resources where we could learn more about today's topic?
Good question. It's there are definitely studies that have been done, not just in oil and gas, but a number of different areas that focus on personality traits. I can think of a few from the UK looking at what's considered the right stuff. That's Rona Flynn, and I'm trying to think of her colleague's name, but they looked at what is the right stuff, interviewed a number of pilots, astronauts, ship's captains, installation managers, and said, what do you consider to be important in the personality trait related to competency or performance of a task? So that would be an area to look for. So Rona Flynn, and I think the last name is Slavin as well. But I'll be working with Energy Safety Canada over the next little while, and we can try to develop a resource of areas that you can focus on. It's difficult to provide a list of reading materials that you can look up some of this information in this format, but I can easily put together a list of further readings that can go with the presentation.
All right, that'd be great. And we can post that with this recorded presentation when we get that up on the website for everyone still online. That should be next week. Now, just to close out and keep us within our time limit here, if you do have any other questions that we can forward on, please send those to safety@Energy Safety Canada, or I'll try and record them out of the Zoom chat there if I did miss any. Just to close out, quick reminder, we do have some additional upcoming webinars with Energy Safety Canada. You can register at energysafetycanada.com/events. Tomorrow, April 29th, we have Home Office Ergonomics with Donald McDonald, a professional ergonomist. May 12th, Mental Health Resilience during COVID-19 and beyond. May 20th, Building Mental Health into Emergency Management and Business Continuity Programs. And May 21st, join us for Workplace Exposures with Robert Waterhouse. Now, finally, please let us know how we're doing. We have a feedback survey that if you haven't received, you should receive shortly in your email. Let us know what you thought of the presentation, and what did you learn? How can we improve? And what other topics interest you, or could we offer additional webinars on? If you haven't registered and you got the link to the today's presentation from a friend, you can complete the survey at the link below, surveymonkey.com/r/ESC webinar competency. That is all the time we have. So on behalf of Energy Safety Canada, I would like to extend my sincere thanks to Dr. Tabor for being here today. He's given us some great information with HSI that I hope we can all implement in our own safety management system. So Michael, thank you very much, and we'll be in touch.
Thank you.